key attributes of our quadratic graphs, or our quadratic functions. And these are going to be a curve called a parabola when plotted on the graph. So this is our quadratic function graph, and you can see it is a curve. So let's look at these piece by piece. Domain, again, always is our x values, and we're going to scan from left to right. Scan from left to right. At our left point, we are going on to negative infinity. Scan over to the right, we are going on forever. So when we have two infinities, we've got all real numbers. The domain for quadratics are going to be all real numbers, always. Our range values, our ranges are y values, and we scan from bottom to top. So you can see we've got bottom to top. At the bottom here, it's going on forever, so we're going to be going on for infinity. And then top, we have this top point right here. So all my y values are going to be less than this number right here. So my range for my quadratics, they're going to be written as inequalities. Either y is less than or equal to some number, or y is greater than or equal to some number. And if it is facing downward, the curve is going down like that, then it's less than, and so then if it's going up, then it's y is greater than. So if it's downward facing here, my range is going to be y is less than, and that point right there, that y value is 6. So x-intercept, just like my linear, these are my points that cross the x-axis. And for my quadratics, I could have none, I could have 1, or I could have 2. Remember, I write those as the number it's crossing, comma, 0. So it goes to the x-axis and crosses there, and it crosses here. These are my x-intercepts. And that's at negative 0.50 and 4.5, comma 0. My y-intercept, same thing as when we had the linear point that the line crosses the y-axis, and that's going to be written 0, comma, y-axis, it crosses that right there, so it's my y-intercept, and that is at 0, comma 2. Alright, again, my zeros are the value of the function at 0, and these are my x-intercepts. That's my zeros. So again, we can have none, 1, or 2. My vertex is unique to my quadratic graphs, and this is my turning point of the graph. So you can see that this goes up, and then right here it's going down. So this is my turning point. So this right here is my vertex. Every parabola has a vertex, and this one is at 2, comma 6. We use that vertex to say whether we have a maximum or a minimum. If the vertex is at the top, so if my parabola is facing down, then we have a maximum. So then the opposite is true. So if my parabola is facing up, then we have a minimum. So if we have it facing down, we have a maximum. And then finally, we've got the axis of symmetry. And our axis of symmetry is a vertical line that divides the parabola into 2 equal parts. So on this graph, it's already defined for us in that vertical line. Remember, vertical lines go up and down, and you can see it divides that each side of this is equal. They're the same. So this is my axis of symmetry. Since they are our vertical lines, we write those as x equals. So this is at x equals, and I look at x equals 2. And this number, how I get that, is the x value of the vertex.